Everyone, today we are going to learn how to use trigonometric equations such as sine, cosine, and tangent in order to find missing sides and angles of a right triangle. So your different trigonometric equations are sine, cosine, and tangent. A little mnemonic device to help you to remember which is SOHCAHTOA. So stands for sine, which is opposite over hypotenuse. Ca stands for cosine, which is adjacent over hypotenuse. And TOA stands for tangent, which is opposite over adjacent. So we're going to first look at this first problem here and solve for our missing side, which is x. We are given a side opposite to 50, which is our given angle, and one adjacent to it, because it's right next to our angle. This here is our hypotenuse, which is across from the right angle. So it's opposite over adjacent, which would make it tangent. So you always put your degrees after your equation. And you're going to do the opposite over adjacent, so 1.8 over x. Then you're going to want to multiply each side by x. So that way your x is in your numerator or top of your fraction. And then you want to divide each side by tangent 50. To make sure x is by itself. So now we can put that into our calculator. So we're going to do tangent. Wait, we got to do 1.8. 1.8 divided by, now we do our tangent. So put parentheses around my tangent of 50 to make sure they calculate tangent of 50 before doing our division. That's going to give us 1.51. So now we're going to go back to our problems here, and we're going to type in x equals 1.5 because we are rounding to the nearest tenth. And since 1 is less than 5, we're going to keep it at 1.5. So now we're going to look at the next set of problems. We're going to look at the third one here. We're given the angle of 24 as our main angle here. We're given the opposite side and the hypotenuse, which is hypotenuse is always right across from your right angle. So opposite of our hypotenuse would be sine. So I'm going to need to do sine 24 equals opposite of our hypotenuse, which is 4 over x. And just like the last time, we're going to want to make sure we multiply each side by x to put x on the top of our fraction. And then we're going to want to divide each side by sine 24 to get x by itself. So now we can go to our calculator and plug that in. So we are going to put in 4 divided by sine of 24 and that is going to give you 9.83, but we're rounding to the nearest tenth, so that will give us 9.8. So we'll put that in as our answer rounded to the nearest tenth. So it says approximately 9.8. So the last type of problem we're going to look at is going to deal with finding an angle, missing angle, when giving a side and another side. So given two sides. So looking at this first one here, we have an adjacent and a hypotenuse, which we go with cosine, because cosine is or adjacent over hypotenuse. So that is the equation we'll be using to solve this. So we're not given our angle in this, so we're just going to use x in place of our symbol here, which is theta, which is sometimes used in place of x for angle. And we're going to put our adjacent over our hypotenuse, or 12 over 13. Now the only way to get rid of the cosine of x is we have to do its inverse. And so the inverse you can type as cosine to the negative 1 power. And then what is inside. So now you're going to want to take that, put it into your calculator to find what your angle is going to be. So I'm going to go in here, back to my calculator, and you'll click the function here to bring up your inverse functions. So that's the cosine and sine inverse function, but we need the cosine inverse function. So we're going to have cosine inverse, and then we're going to do 12 divided by 13 by going back to our main buttons. And then that was going to give us our angle degrees, which is 22.6. But we need to round to the nearest whole number. 6 is greater than 5, so it's going to be 23. And that is how you use trigonometric equations to solve for missing sides and angles in a right triangle.